All right, class, I want to review how do we add and subtract with significant figures. Here was an example, 12.5 plus 13.5. Make sure you are lined up at the decimal place. 5 plus 5 is 10. So I write my 1 up here, 0 here. Bring down the decimal. 1 plus 2 plus 3 is 6. 1 plus 1 is 2. Now I'm going to need to decide, do I round up, do I round down, how many significant digits? This goes all the way to the 10th place, and this is the 10th place. So I can draw my little dotted line here, and actually 26.0 is already the perfect answer. Now this one, I can see already it's a little different. 2.0 goes to the 10th place. 3.456 goes to the tenths, hundredths, thousandths place. That is much more precise. My answer cannot be that precise. I don't know what's happening here. That's a mystery. So I draw my dotted line like that. But I'll do the math the same. I could do this by hand or in the calculator. And I will get this answer, 5.456. So now, am I going to say 5.4, or will I round up because of the 5? We learn in math class to always round up when this is a 5, so my final answer is 5.5. Over here, I could bring down the 3, make this 9 and 0, but you know, again, this is a mystery. What's going on right there? I don't know. So a dotted line, I can see that it's 0.9. Or would I round up? No, that's just a 3. That's less than 5. So my final answer is 0.9. Let me scoot over. All right. This one, it's pretty clear that there's a lot of extra precision in this number. So even though I'll do the math the same, I know that I need a dotted line down here. I'm going to stop at the tens place. I don't go to hundreds, thousands, or 10 thousandths. That's much too much. 13.2 is my final answer. These extra digits are not significant in this case. Now I'm going to do subtraction, but it's the same rules. 6 minus 3 is 3, 5 minus 2 is 3, 4 minus 1 is 3. Well, look at that. It's significant to the end, so it's 333. If I wanted to be very precise or clear, I could even put 333 point. I can put it there. It means the same thing because all 3 digits are significant. Here, this is also subtraction. Now remember, when it's 0 on the top, it gets a little strange. So 0 minus 5 is not possible. I need to make that 10, which means I need to borrow. 10 minus 5 is 5. 4 minus 0, 4, 0. That's my answer. Lucky for me, they are both significant all the way to the last digit. This only has one significant digit, but it's in the tens, hundreds, thousandths place. This 0 at the end is also significant because zeros at the end of a number with a decimal are significant, so they are both significant up to the hundredths place. Here I will subtract again. Oh, see, I did this wrong. I'm looking at this like, what? That's not possible. You know why it's not possible? Because I have the bigger number on the bottom. So let me rewrite this. It was 3.0 minus 0.021. Now I have to imagine that there's like little zeros right here. But first, let me draw my dotted line so I don't forget. I can't go past the tenths place in my answer. So I'll draw zeros here, but 0 minus 1 is not possible. I'll make that a 10. But I have to borrow. Well, I can't borrow from the 0, make that a 9. I can't borrow from that 0, make that a 9. I have to borrow from the 3. Whew, I found something to borrow. 2. 10 minus 1 is 9. 9 minus 2 is 7. 9 minus 0 is 9. And 2 minus 0 is 2. I could flip that, make it negative if that's what the problem required. But now I need to decide how to round. Will I put 2.9? No, this 7 right here means I need to round up. So some students like to tell me, oh, well, it's 2.10. Well, remember, 2.10 is the same as saying 2.1, which is much smaller than 2.9. In order to round 2.9 up, I have to go to 3.0. That is the next larger number. 8,000 minus 4,001, you will end up with this number. And that's already correct. And in fact, I'm pretty sure the problem had a decimal point right there. In that case, that's where my dotted line would go. Now let's pretend like I had it originally written. There were no decimal point. Then I have to draw my dotted line differently. It would go here. And then what would I do? Well, I won't round down to 3,000. 3,999 is much closer to 4,000 with no decimal point. That's not significant. It's just an estimate about 4,000. In the word problems, we had some more examples. Again, I'm subtracting, so I'm going to remember my dotted line is here, but I need to give myself a 0 so that I can do my proper subtraction. Make that 2 and 0 is 2. That, I'll bring down my decimal point. So it's like 0 to 0.99. Now I know that's 0 because zeros in the beginning of a number like that, they don't mean anything. They're not significant. And I've got an extra digit here. Again, 2.9, just like it did here, we'll round up to 3.0. This one was funny. It was 25 minus 15. Well, that's easy, right? That's 10. But actually, you've got to remember that if your dotted line is here, that means both of these digits need to be significant. It goes all the way to the end of the number at the ones place. So to make that 0 clearly significant, I will add a decimal point. That is 1, 0, 10 exactly. The final example here, we knew, and what did we got? We got 7. But the question that we read said this was about 47,000. I don't know all the way to that. It was about $47,000. So I can't say my answer is $7,188.12. I don't know it that exactly. It would be lying to tell you that I did. So my dotted line doesn't go here. It doesn't go here. It actually goes all the way over here because these zeros have no decimal point. They are not significant. So this is where the numbers begin being significant. So I have 7,000 something. And it's a little strange, but the way we write that is 7,000, no decimal point. This is an estimate. If this were large, like maybe 7,888, I would round up to 8,000. But I don't need to, I'll round down to 7,000.